Anything in particular? Okay, let's do a code review of this thingy. Is that gonna work? Let's hope I copied it. And not some password was my clipboard. Alright. So this, you could do a different way, but how you did it is fine. The different way would be a trick, and I guess you don't really need to do the trick. So you're fine there. So looping over the chars. If the character is an int or if it's negative. So you could merge the, let me, raw. Okay. So you have an if, and inside the if you have a duplicated condition or an else. So you could rewrite this to be that. So you can remove one layer of nesting and extra checks by just like turning it on its head. I guess if A or B, if A, else B, else. So this is what you had. Oops. And you could rewrite it as if A, else elif B, else, right? Like this is equivalent to this. Assuming A and B don't have side effects. And in your case, they don't have side effects. And if they did have side effects, that'd be confusing anyway. Hello, viewer. Or view, or whatever. Hi, Serp King. So that's that. Bool int list equals false. You can turn that into just not int list. Sign flag equals true. In this case, I assume you're only setting it to true or false. So you can get rid of the equals true. So if sign flag is set and there's nothing in the int list, return 0. That's odd. That means if I you have the same thing here. So if I write plus minus or minus plus, you're going to always return 0. Which I don't know if that's intended. Okay. Okay, yeah, so that's as specified, so that makes sense. You have to build edge cases. Well, I mean, this case looks kind of suspicious. This looks suspicious. Like, I don't know why you're checking if int list is empty. It just looks kind of out of place. Oh, so you're saying, so sign flag and neg flag are friends, looks like. So sign flag is set if a sign was given, so a plus or a minus. Neg flag says which character that is. So here, because it's a minus sign, you set both to true. And I imagine you set one to true, one to false, and plus. So in your plus, you only set the sign flag to true. Neg flag is assumed to be false because it was set earlier. Cut short into a substring. I don't know what you mean it could be cut short. Are you modifying S? No. I don't know what you mean it can be cut short into a substring. Okay. Okay, I gotcha. That makes sense. Makes sense. Do you have your test suite here somewhere, or is it part of LeetCode or something? All the examples and such? Yeah, I gotcha now. That makes sense. I think I would have done it differently, but I think that's just preference. You wish? Well, you can make it. Make your own test cases. That's what I do. Because it's rare that somebody hands you a pristine set of test cases that are like comprehensive and such. So the char is in the indict, appended to the int list. I would call int list digits. Let's just rename it digits, because it has the digits, the 0 to 9, and it's a list of them, so hence the plural. So if int list is empty, so you say int list with digits. So if we hit a white space, if it's empty, continue, otherwise break and return digits. If they have a negative sign and then a space, so here you can do the and not digits again, and you don't need to do that, you don't need to do that. So here, now that I cleaned it up a bit, it's a bit easier to see that it's checking sign flag twice, so you could instead write sign flag, then do both of these things. If not digits, else if digits, and because these are like the opposites of each other, then you can replace them with else. And my preference is that I never have an if not, unless it's a long chain of ifs, in which case that's probably a bad idea anyway. But if I have this kind of situation, I just I invert the condition and then I swap the two branches. So that would be this. So I think this, it's a bit shorter than what you had. So it's easier for me to scan. But it may not be better, I don't know. This is hard to look at. Why is that? Is it my face? Like if you've been programming a while, you'll notice patterns, and you'll have some idea of, if I see this pattern, then it could be written this other way in this other pattern. And what I do is I try it, I like change it to that other way and see, oh, does it make sense now? Or does it still make sense? Or is it better or worse than what it had before? And if it's worse, then I undo my change. If it's better, then I keep the new version. So if we had so what this is saying is, if we had a sign flag, wait, hold on. So maybe, so my transformation was wrong, because if you had a sign flag, or if you had digits, this is not an and, this is an or. So my transformation was incorrect. See, sometimes I try it and then it turns out it doesn't do the right thing, even if it looks prettier or something. Let's see. Well, you don't need this else continue, because this is the end of the loop. Loop ends here. Or not ends, but you know. Like there's no code that would run after this continue if the continue wasn't there. So you could just delete the continue, and if you delete the continue, you can delete the else. So we'll do that. And we'll do it here too, because the same thing. Hello. Can you give me a pronunciation guide for your name? It doesn't resist being made pretty. It's just you need to work at it and keep like changing it, like little bits here and there, you know. It's like when you're doing art, you're not going to make the most magnificent piece of artwork, like the best illustration, in the first go. You're gonna do the broad strokes, and then you're gonna tweak it a lot, and you'll probably undo some of the things that you did, depending on the medium. Do I always do this type of review on my own on my own projects? No. So one thing about code review is the things that I notice in other people's code, I generally apply to my own code, but I don't catch everything. If somebody else reviews my code, they'll catch a lot of things I missed. So no amount of me looking at my own code will make it good enough, you know? Though I could wait a few months, realize, like, now have a fresh set of eyes on the code, and I can review my own code in this way and fix things up or whatever. But usually I do this with other people's code because my mind is different than their mind, and I would like other people to review my code because their mind is different than mine. Okay, let's Google Translate your name. João. João? Is it João or João? Keeping active with projects and whatnot to get up to speed. I don't know what you're talking about. So there's more of this equals true stuff. More equals true stuff. Make this not. Do that. In the moment you end your code, you probably have things to refactor. Oh yeah, I definitely do that a lot. I do that all the time. Well, I mean, it depends. So sometimes I'm just trying to get something to work or debugging something, and I don't bother with that. Because if it's not working, then no amount of refactoring is going to fix that. Well, I mean, it could accidentally fix it, but it's very risky because I don't have a good, like, it's hard to notice if something isn't working, if something is broken. It's hard to notice if I'm making it worse, if I'm adding new breakages. Whereas if it's working, it's easier to see if I'm breaking, like adding new bugs. João? 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 There's too many vowels. I don't know how to put them together. Maybe you can record yourself saying it and then send me the recording. Oh, there's a João. João. It translates to John. Okay, so here's that thing that I said applied up here, but didn't actually apply up here, but it is applying here. So both of these cases say and digits. And these are opposite of each other. So you could say if digits, then do this. And because we know digits is true, we can drop this. And because we know in here that sign flag is false, then we don't need to check it again. So we can do that. But actually, both of these are the same, so we don't need to check sign flag at all. Like both of these pieces of code are exactly the same. So we just delete. That's nicer. Maybe. Probably. This is probably a lot nicer. Cause João. João. Is it kind of like French where the last consonant is silent? João. 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 Language is hard. Okay, so you see what I mean where like you can cut down the lines of code just by like looking at it and doing some simple transformations. I mean, there are, in order to get it like 3 times shorter, you need to do more advanced transformations, but here we're doing local, like there's a span of 3 lines of code, we can shrink it down to 1 or 2 kind of thing. So one note is I would not move this if into like, I would not do this because all of these checks up here are checking the char, the current character. So it'd be weird if we, instead of checking the current character, we checked some other condition. So like this outer if would be consistently checking char. And this is saying if it's any other kind of char, then do this thing. So I think it makes sense to have it as you wrote it, where it's split up. Joom. Is it like a Joom? Joom. 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 I think you need me to. I need a clip of you saying it, like very slowly, in an American accent. Then that would tell me what's up. Joom. Jo. Jo. Joom. Well, there's no stop there. Joom. Jo. Is there a stop? Is it Joom? Or is it slur? Joom. 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 So if digits. So do we need to do this digits check? Like, does what now handle that case? So if L is empty, then stripped int will be 0. So I think you could delete this if digits, because what now will handle it. So let's just do that. And we can do, so we can't do it here because this affects control flow. We can do it here. We can say, because if not digits, that means the digits is empty, which means we could do this. And that is the same as return 0, because what not returns 0 if digits is empty. And now we can try merging these. So you can merge them by saying or that. And if sign flag or if digits or sign flag and not digits, there might be a. So in cases like this where I don't want to think too much because there's too many cases, I go to my trusty friend Wolfram Alpha. Hello, Muscle Mario. I was thinking about what I said. Like when you left, I said you're incoherent. So I guess that stuck with you just as well as it stuck with me. So I could throw this in Wolfram Alpha. Wolfram Alpha doesn't like these programmer identifiers, so I just use A. Well, I guess S is better. S for sign, D for digits. And maybe it'll understand now. So it interprets that as a Boolean thingy. And here it gives you other forms of it. So we could just say digits or sign flag. So that second or is useless. So that deleted 2 lines of code there. I'm sorry to hear that, Muscle Mario. So I have no clue if all the transformations I've done are behavior preserving. I didn't run this program at all. I don't even know if it worked in the first place. But if you have a test suite, then you can do these changes pretty easily and just run the tests. If they all pass and they're comprehensive enough tests, then you know you didn't break anything severe. But yeah, we can whack it down. So it's 66 lines now in my editor, and it used to be 77, so I cut 11 lines out so far. It did what? What I do? Oh, and there's the same, possibly the same thing here. So we know that not digits means that what not returns 0. So we can do this. It did what? Oh, it did pass the test? I meant like, ideally you have a way to run the tests on your machine, or like a way to run it rapidly instead of uploading it to LeetCode. But I mean, you could upload it to LeetCode every time as long as there's no penalty. If there's a penalty for every attempt, then probably don't want to do that. And you should have your own local test suite. So we can say if this or if digits. Because we could, well, first we can do this. Whoops. We could turn the else into that. Then we can merge this and this. Say that or digits. And this comment, who knows? No. Comments are annoying in refactoring. I'd be a great competitive programmer. Well, it depends on what they judge on. If they judge on how many lines of code you have, then, or like how readable it is or whatever, then maybe. But I think competitive programming usually goes on other metrics. They judge on other metrics, and like how fast you can develop the solution, or what's the algorithmic complexity of the solution. And I'm interested in those things, but it's just too much anxiety in the pressure of getting the solution out fast, So we can do the same I'm lazy, I'll just use Wolfram Alpha trick for this. S and not D or D. That's probably S or D. So just or digits. And hey, that's kind of similar to the plus thing. Oh, actually, we could do the same thing here. Or digits, that. And we had S and not D or D, S and not D or D. So we could just do or digits. Kaboom. And now these two are looking very similar. They judge if you are doing it the right complexity. Well, I don't think that's useful. I mean, I think it's useful. It's not something I care about. It's not magic. It's Boolean logic. So now that these are similar, I'll just move this up because I know char, if char is plus, then it's also not this, and it's not in the dictionary. So I move them together just because they're kind of friends, I'll delete these comments because I don't like comments. And now we're down to 58 lines. We can merge these two blocks because the only difference is neg flag. We can say neg flag is char is equal to minus. And then we could say or char equals plus and merge these two. Right? So the negative flag, if it's a minus sign, then it should be, the neg flag should be true. If it's a plus sign, the neg flag should be false. elif Wait, okay, I'm waiting. Count Soren. Are you talking about this line? Or something else? Or did you want me to merge it here? What did I do by the neg flag? Okay, I'll take it slower this time. So we could, this is like without anything crazy yet. We could do this, but put false here, right? We could set neg flag to false whenever we get a plus. This is gonna do nothing. Like if we were gonna be extra careful, we could say assert that neg flag was already false, and then we set it to false. So if we messed up, like if this line of code is bad, then this assert will fire. I mean, we could be extra pedantic and say is false, but you know. So you understand this? Why, like, because your loop. I can merge one more. I could, well, the thing is, I could merge one more. I think I could, but I wouldn't do that because white space is pretty different in the problem domain than plus and minus are. But I see what you're saying because this is the same as this and this, so yes. But I'll get to deleting this anyway later. Or I think I can delete it later. That's a good observation. Yes, we are doing the same thing. So now that we have neg flag false there, we could say that this, we know this is true. Wait. We know that that's true. We can negate it to make it false. That doesn't really make sense, so I'm going to undo that. It makes more sense here. So we could say char is equal to minus. So the negative flag is set when char is equal to minus. And this will always be true because we checked it up here. So this is, like, the change I just made is weird on its own. But hopefully it should still make sense. What is that? What is this? So you can, so just like you can add things and get a number out, you can compare things with equals equals or not equals and get a Boolean out. It's not, you don't, like, you can use equals equals outside of an if case. You can do it in an expression like this, and you get a Boolean. The parentheses were just to make it easier for your eyes. They're optional. But if you do it like this, then like it may be hard to see what the heck is going on here, because often, like, if you're reading this, you might think that's what's going on, but that's definitely not. I mean, that would be nonsense in Python, but it's just like a visual aid to say I'm assigning this thing to neg flag. Yeah, some people can't read it, so may as well cater to the masses and just add the parentheses, because the people who can read without the parentheses can also read it with. So in this case, we know that this is true. The same expression would be false here, like inside of this code. So this line of code is saying that neg flag should be set to false because we know char is a plus in this if branch. And because char is a plus, it's not a minus, which means this would result in false, right? So instead of assigning it to false directly, we could make the code a little more complicated and say this. So does that make sense? We're 2 steps away from the magic. And note that we're not changing sign flag at all. Like, we're not touching that yet. So the next step is delete these assertions because I just added it just to sanity check myself while I'm uploading a delete code or something. But now, strangely, this is character for character identical to this. So we can merge the if conditions. So we can do this or that. So if we just did that, then this is dead code. And we could verify that by saying assert false if you really want to be extra careful. Because sometimes, you know, it can be a bit more complicated. So in general, I would make an assert false here just to say, or like throw or raise error should not have been called, or exception, whatever they call it. Too many languages call it a different thing. And then you can just delete this dead code because this stuff is handling it for us. Bam! Now we can see the whole loop on one screen. Magic. We're not done with this loop though. We're not done with the loop. So the observation that Counterman made is that we got these 2 lines and we got these 2 lines. Let's highlight both at the same time. Those are identical. And in fact, we're also doing this stuff down here, which is also the same. So we know that returning will exit the loop. And we know that if we do a break, it'll also exit the loop, but not exit the function. If we put a break here, then that's going to go to this line. Whoops, that was totally wrong. Break goes here. So this break will go to this line of code. So if we did a break here, it's going to execute this, and this is the same as what it was doing before when we had just the return. So let's get rid of the return and just use break. And the same logic applies here. We can do that. The same logic applies here. We can do that. Yeah, we'll get there. We'll get there one step at a time. So, well, I don't think we should remove the sub-ifs. I don't know if you caught my comment earlier, but this outer if is only checking char. It's only checking char. Only checking char. I think it'd be weird if it checked other stuff as well sometimes, because like this is implementing a parser. The first, like logically, the main thing you care about is the state of the state machine. But this is like an ad hoc state machine, so the secondary thing is the current character. And it'd be confusing to switch on both at the same time. So when do you mainly use case statements? That's a good question. I think in this case I would use a case statement, but Python doesn't have case statements, so Answer doesn't matter. Yeah, I get what you mean, counterin. We could save a line. If we're saving lines, then we could do and we could do this. But I think that's a bit less readable. No, we can't do this. We cannot do this. Because if the character is a space and this is false, like it's not this, either we don't have the, if we don't have digits and the sign flag is not set, then we don't want to go over here. We don't want to execute this break. So we can't just put all this in one line. So because we're trying, so this code is trying to skip leading white space. So while there's white space in the beginning, we want to skip it, skip it, skip it. But if there's space after the number, after digits, or after a plus, or after a minus, then we want to stop. Yes, elif is else and if. In Python, you can't write else if, I think. Maybe you can. Else if. I don't know if you can. I don't remember. So counterin, I think in some cases what you're saying might work, but in this case it doesn't work, unfortunately. It'd be neat if it did, though. So we shorten this loop. Delete that comment. We'll delete this comments. We'll delete this comments. I mean, I would delete this comment, but whatever. Are bools the fastest and smallest data type in all languages? No. There's no such thing as a fast data type, because data types don't have speed. You know? Data types do have size. In some languages, booleans are the smallest. In some languages, they're the same size as everything else. In some languages, they're the same size as some other things. So it depends. In some languages, it's larger than other things. But char with space and char with minus. Yes, I think that would make the code harder to read, though. But maybe not. So there's two ways to think about this loop. One is, given the next character, what do I need to do? And another thing that you can think about is, I'm in this state. Here's what I would do for the different characters. So let's say this is original and this is inverted. So let's invert things. So if sign flag are digits, then we duplicate. We can say else, and then we duplicate, and then we can delete duplicate things. So we know this is true, so we can replace this whole thing with break. We know this is true, so we can delete this. And we still need that, because that's not changed. And we can delete, because both of these bodies are the same, we just delete that. Down here, we know that it's not true that it's both of these are false, so we can inline that case. So there's that. We know that this would just be a pass. So you could rewrite it like this, where this really means have we encountered anything before, any special characters? If we have, then we need to do things a bit differently. And if we haven't, we need to do things differently. The disadvantage of this approach, as written, is we have this duplicated stuff. You could do it a third way, where you mix the state and the next character conditions together. That could lead to better code. Let's try it out. But in general, I think it doesn't. How do you disassemble Super Metroid? Very carefully. I'll get to your question in more detail in a bit. I've used bools at the end of checks to make referencing them easier. I just check the bool condition. At the end of checks? What do you mean at the end of checks? Debt Hunter. From what I can see, have 3 outcomes here. Break, set flag, and digits append. You should be able to write it as 3 ifs. Yes, you should be able to, and I'm going to do that. You can delete the first if. In the inverted thing? You're right. You're right. You're right. Try to say your name. Dang it. I'm struggling with your name. João. Joaun. Yes, you can delete this because we already have an else. And we know that it can't be true that this is... We know if this is true, then this is false. And we know if this is true, then this is false. And because we know that, we can reorder these. And if we reorder like that, then we can delete this because these else and the if-else, else-if are the same. So good observation. And we could do something actually similar here, where we say if it's not that, then break. But I think it's a bit clearer to always have, because these are all positive checks, positive check, and not. If we have a negative check in there, that can throw you off. But yeah, that does make it nicer. Thanks. So let's try the mix thing, which is what Counterman said. Oh, let me get to time travel's question. How do you disassemble Super Metroid? I used so if you're referring to my projects, the Super Metroid disassembly, I used a disassembler called Dispel. If I was going to do it again, I wouldn't use Dispel. I would keep searching for another disassembler. But it's okay. So this is a disassembler. So I took Super Metroid ROM, ran it through this program. Then I ran a bunch of... Well, actually I modified the source code for this because there were some bugs or something. I don't remember what I changed exactly. Yeah, mix will mess it more, but maybe it'll look nice. Maybe we'll see something interesting. So I ran it through this tool, and on its output, I ran a bunch of scripts. I think I might have them... Actually, I don't probably have them in here, because I already did all the dumps. But so it makes, this program makes output in some form, but an assembler doesn't, like the assembler that I wanted to use, so this converts object code or machine code into text source code, and then an assembler is the opposite of this tool. So this is a disassembler. An assembler is the opposite, where it takes human readable text assembly code, it converts that into object machine binary code. The thing is, there's no standard for what the text format is. So this disassembler put it in some form that it preferred. I had to munge it in a way that would be acceptable to the assembler. I was using WLADX. So we're using WLADX to assemble. So a lot of the early work was just getting the output of the disassembler to work with the assembler. Does that answer your question, time travel? And then the real hard work is going through all that disassembly, figuring out what's data and what's code, where the disassembler messed up because various reasons, because the processor has state which affects other instructions. Figuring out the names of functions, names of variables, and all that stuff, and documenting the code. So that's the majority of this project, the Super Metroid disassembly project. As you can see, no one's worked on it for, well, you can't read that. No one's worked on it for a few months because I started streaming, and that's been taking my time. But I would like to stream this, but I'm more excited about some other projects right now. Okay, back to this version. So let's well, I guess it doesn't matter which one we do. Well, let's go back to the original mixed. So we can say if that and this, then break. If this and not this, then do that. If this and then break. If this and not this, then pass. So I'm just squashing all of the ifs, like the inner ifs, I'm moving them into the outer ifs. And then we can take a look at some similarities or differences. So we can see that we can do this, move that down there, because we know that all of these ifs are disjoint. So we can freely rearrange them, except for this final else, the catch-all. We can't move that to the top or something. But if we do this, then we can merge these two, merge the else and that check. We can do the same here. We can move this down and then delete it. And yeah, it looks all right. I still would like, this is repeated, so I still like have the, oh, so we could merge this and this, I guess. Let's see what that would look like. So we have a not here. So if, let's move that. Let's move that. And then we could say if else. So here we need to do the else clause. I mean, technically we would need to repeat the whole thing, but I think that's just break. I guess that's what we had earlier. And And here we can move this inside, so we can do that. Let's compare that to the original. So the point was that we could merge this and that together. But we can't merge them completely because we still need to distinguish this thing. So that's what we're doing here. So we factor that. I mean, it's definitely shorter. This is definitely shorter than this. And it's also shorter than this version as well. But I think it's a bit more awkward. Let's leave that. Because it's mixing, there's a check for some state, and here's a check for the character, and then this else. But like this else used, like for this thing, this else means it's any other character. It's a character we haven't handled yet, or we haven't handled in these other if conditions. But this else doesn't mean that. This else means if it's not a digit and it's also if it's not a digit and it is, and we have parsed something. We've either parsed a plus or minus or a digit. Which puts more mental strain on my brain. But I mean, maybe if that's probably just because I'm used to this because we've been working with it for a while. And this might be easier to grok. Do you like moving the char conditions to variables? You mean like putting this in a variable? I should be able to make it shorter. I could. Can you show me counter-ren? Because I think I'm missing something. Maybe I've just been staring at it too long and I'm missing something. I agree that ignoring, like, scanning past the pluses, or not pluses, the spaces would be, doing that as an early pass would be a good idea. So that would change the algorithm. So that would be another thing that I would do, because that matches how I think about the problem better. It's definitely something good to try. That's what I would try. But I want to move on to the what now function. João. I'll share this code. I'll share this code. Because xclip isn't copying the thing I want. Secondary selection, secondary clipboard. xclip-o selection clipboard. Oh, because I don't have... I guess I could just cat the file. I need to work on my clipboard nonsense. So here's what I have so far. You can use that as a basis counter-in to show me your idea. Because my brain's gonna be tired looking at this code. So let's look at what now, and let's try to figure out what the heck it does. So we know that what now is called with digits. So let's rename L to digits. Digits. Let's rename V to digit. Stripped int. Why is it called stripped int? I don't know why it's called stripped int. So this looks fine. This can just be, you don't have to compare against true. You don't need to do multiplication, you could just do minus, like minus sign. Negative x is the same as negative 1 times x. Yeah, I have no doubt we can merge the breaks, but I think to do that you would need to duplicate conditions. Stripped it out of the list. What do you mean by stripping? Can you define stripping for me? Because maybe I'm using a different meaning. So for this, we can use min and max. This is common in graphics programming, where you have some number and you define a maximum for it and a minimum for it. If it's within the bounds of the minimum and maximum, then just leave it alone. If it's outside the bounds, if it's too small, then set it to the minimum. If it's too big, set it to the maximum. That function is called clamp. Don't mean it in any technical term. Well, this isn't removing anything from the list. And when you say strip, I think of remove. Just taking the digit from the list. Sure, but that's what iteration does. It looks at every thing in the list. So the for loop will do that. So I don't see what stripping means exactly. It's a bad name. Okay. Well, I mean that's a simple change, and it wouldn't affect the length of the code or functionality of the code or anything. But for this, ideally we would write return clamp min is this, max is this, and then you would have define clamp x min max. So let's just move this code over. X. So this is max. That's max. This is min, and min. So now, assuming you know what clamp means, then this code is nicer in my opinion. And I think this is a bit more beatable because before, it's hard to see that this is the same as this. Especially because like you have the 2 times 31 in many places, but they're in different. They're really just two different numbers that happen to be like you happen to express it this way for both, but they're different. And it's hard to see that this one over here is the same as this one, is the same as this one, but it's different from the other ones, you know. Whereas if you have variable names, then it might be easier to see. You're not familiar with clamp as a term or something else? This is just transforming the list of digits to single numbers. Yes, what now is not a good name. However, one thing I would do is, now that we only have one call of what now right now. Like this, these are the only references highlighted in yellow. These are the only uses of what now. It used to be that in the original code there was many calls to what now. But now we only have one, which means we can inline this function. We can move this function body into the place it's called. And in this case, it's very simple to do. Because we renamed L to digits, and it's the same variable name, we have the same variable name here, and because we're just returning, we could just delete these lines, and then poof, we've inlined the function. So maybe it makes sense to not name it at all, and just have the code there. Not familiar with clamp? Okay. Well, learn what clamp is. I would definitely make a function called clamp. Or if you don't want to make a function, you could still say min is this, max is this, and you write this. Well, stripped int. Like instead of making a function, you can still make the variables so it's easy to see what's going on. Yeah, that's how I would write it. Je That's how I would write it. But I don't want to get into too much opinion. But yeah. So aside from like if we, I don't know, I like the original. Out of these three versions of this loop, I like the original. So I'm gonna keep the original. So with all that finagling, we brought it down to 52 lines. It's not always the best metric. For example, I would put this into a clamp function, as I wrote before, and that'll add a few lines. So line number isn't like the ultimate like signal, and we have some duplication, but if you factor it out, I think it looks a bit worse. But keeping the algorithm the same and such, and just doing some basic local transformations, we can shrink it down to like 2/3 of the original size. Where is it? It used to be 77. 77 divided by 23? No, 52. What? 52. 52 divided by 77. So we chopped off 32% of the function. You can take the max of stripped int and int min to clamp it. Yes. Yes, but I think that is less readable than having a clamp function. And technically it also requires more checks and stuff. But we could do that. But then I can't call my variables min and max. Because I want to call the functions, the min function and the max function, and you know. Hello, Chamichner. Welcome to the world of engineering. Anyway, I've been drinking a lot of tea and water, and I need to pee, so I'll go do that. And then I'll switch gears back to banging my head against C++ code.